Hey y'all, this is Miss Michelle, and I'm going over the 4.1 notes over polynomial graphs and writing their possible equations. We did a little bit of this last unit, but we're going to dive a lot deeper this unit. So let's look at what we did last unit. So we were given a parabola, and we have a degree of 2 right there, so I should have 2 solutions or 2 x-intercepts. So my first x-intercept is going to be negative 1, 0. And my second one is going to be a positive 3, 0. X-intercepts and zeros are the same thing, just written different. So here are my two zeros, negative 1, 3. And then to write it in factored form, I'm going to change the signs. I have x plus 1 times x minus 3. Again, if you were to solve this factor x plus 1, you would set it equal to 0 and solve and subtract 1 from both sides. So that's how we would get x minus 1. All right, let's look at the next one. I have this cubic function, okay? So I should have 3 solutions, which I do have 3 x-intercepts. So my first one is negative 3, 0. I have negative 1, 0, and then a 1, 0. Zeros are the same thing as x-intercepts, also roots or solutions. So negative 3, negative 1, 1. I'm going to write this in factored form. So I'm going to change the sign. So x plus 3, x plus 1, and x minus 1. All right, so let's go look at what we're going to be adding on for this unit. So we are writing possible equations. The first thing we're going to look at is whether or not it's an even or odd degree. And when I'm saying even, that means we can have the degree of 2, 4, 6, etc. And an odd degree function is 1, 3, 5, 7, blah, blah, blah. And remember, the fundamental theorem of algebra, my degree tells me how many solutions I have. So if I have an even degree of 2, like that parabola, I'd have 2 solutions. Okay? Looking at a graph, an even degree function, okay, my arrows, okay, or the ends go in the same direction. So they're either both going to go up or they're both going to go down. If I have an odd degree function, that means my arrows or the ends go in opposite directions. So one end will go down and one end will go up. Okay, so those are even and odd. The second thing we're going to be looking for is whether the leading coefficient of my equation is going to be a positive number or a negative number. Okay, and it's all about the right side. So if my right side goes down, I'm going to have a negative leading coefficient. If my right side goes up, I'm going to have a positive leading coefficient. All right, so let's try some examples. Example 1. Okay, the first thing I notice is my ends are going in opposite direction. My left end is going down, my right end is going up. So this is going to be an odd degree function. More specifically, this is a cubic function. And then I look at the right side of my function and it is opening, or it is going up. So this is going to be a positive leading coefficient. Let's look at my second example. Okay, looking at my ends or my arrows, both are going in the up direction. So this is going to be an even degree function. This is also a quartic, just for added information. I'm going to look at my right side of my graph and it's going up. So that means it's going to be a positive leading coefficient. Looking at my third graph, okay, looking at my ends, they're both going down. So this is going to be an even degree function. And again, this is to a quartic. All right. And then looking at the right side of my function, this is telling me I'm going to have a negative leading coefficient. My last graph, so looking at my ends, they're going in opposite directions. So this is going to be an odd degree function. This is also a cubic for added information. And then looking at my right side, it's going down, so that means I'm going to have a negative leading coefficient. All right, try the U-tries and then check the key.